Here, this is today's session model paper discussion. So, here, student, we will go through this way. Here, we will move on first question. Okay. Here, this question regarding turning effect of a force, your lesson in grade 10. First question is the wooden strip AB is pivoted to the wall at point O. Is it audible? Okay. The wooden strip AB is pivoted to the wall of point O. The A and B, there are two ends. A and it is upward force, it is 8 Newton. Then B, it is Y, 8 Newton for downward. Okay. There is a wooden strip. Center is O, A, B, and one end it is 8 Newton. The other end it is downward force also it is 8 Newton. Okay. First question they ask, what is the name used for above setup? Can anyone tell me what is the force? It is an equilibrium force, 8 Newton for upward, 8 Newton for downward. Can you tell me what is the setup? What is the name of the setup? Can you tell me?
Couple of forces.
Yes,
Couple of forces.
yes. This is a couple of force. What is the meaning of couple of force? Can you tell me what is the meaning of couple of force?
Equal force with different line of actions acting in opposite directions.
Yes, very good. Equal coplanar. Equal coplanar forces. So equal magnitude forces, acting on the opposite direction. Here, this is 8 Newton for upward, the other end for downward. This is what? Two coplanar equal magnitude in opposite direction. That's why it is called as couple of force. Okay. Is it clear, student? Then, second question. In which direction will this setup rotate due to the X and Y forces? Can you tell me this setup rotate due to the X and Y? What is the direction?
Clockwise.
Yes, very good. It is clockwise direction due to X and Y. Okay. Then third question they ask, name other two instances where this type of system force can be seen. You all know the many of couple of force in your day-to-day life. Can you tell me examples for two instances where type of system? Can you tell me?
Opening a
And
tap.
screwdriver.
Yes.
Opening a tap and using screwdriver.
Yes, turning a steering wheel, then also open or close a bottle cap. This is also go with couple of force. Okay, there are two instances. Turning a steering wheel and open or close the bottle lid. Here, fourth question. The two forces of 8 Newton are applied at two ends. 50 centimeter aluminium strip which is loaded at O point. They ask what is couple of force. You all know what is the meaning of couple of force. Dear student, carefully read the question. There are two forces. One force is 8 Newton for upward, one force for 8 Newton downwards. They ask what is couple of force. So first of all, we have to calculate moment of the force. Okay. Can you tell me what is the meaning of moment? Here, first we have to calculate moment of force. Here, moment. What is the formula of moment? F multiplied by D. Moment equal F multiplied by D. What is meaning F? It is force multiplied by D mean perpendicular distance. Here they ask what is couple of force. So we have to calculate first moment. Here moment equal F multiplied by D. So what is the force? They given us 8 Newton. What is the distance? Here 2.5 centimeters. So we have to convert it into meters. Then after what is the answer? What is the moment of force? Student?
2.
Yes, 2 Newton meter. That is the answer. So couple of force of this wooden strip is 2 Newton meter. Then the other, okay, all are clear. Can you remember what is movement? Can you remember?
Moment of a
Product.
force is like measuring its ability to cause an object to rotate in a specific point.
Yes, very good. Product between magnitude of one force and perpendicular distance between lines, it is movement. They ask couple of force. So first we have to calculate moment. Formula for moment is moment equal F multiplied by D. Answer is 2 Newton meter. Then we will move to B part. Here, a uniform beam AB kept in equilibrium on a knife edge at the point P. Here there are two ends. AB kept in equilibrium on a knife edge at the point P. Here, first question they ask, if a weight of 6 Newton hang from A, find the initial moment. So you already know formula of moment equal F multiplied by D. Okay, they ask find the initial moment. Can you do that?
Teacher. So you have to get the moment formula, and you have to multiply by 6 into 75. The answer will be 450 Newton anti-clockwise, and you have to calculate
Okay.
the distance of x, and that anti-clockwise movement is equal to clockwise movement, which is 450 is equal to 9 newtons into x. Then you divide it, and finally you will get 50 centimeters.
Yes, very good. Here,
Excuse me, teacher. They have given 75 centimeter, right? Then we have to divide it by 100 and we'll get 4.5 Newton meter, no? Not 450, right?
Oh, yes, yes, teacher.
yes. They ask if a weight of 6 Newton is hang from A, find the initial moment. Here, one end. Distance here it is 75 centimeter. We have to calculate. Then what is the answer? What is the answer?
4.5.
Yes, 4.5. Here, this is the initial moment. So, can you calculate x value? How can we calculate x value? So, then look at the picture, student. Here, A and B, that uniform beam is in equilibrium on a knife edge. So you all are know clockwise movement equal to the anti-clockwise movement. So that's why we already find out the anti-clockwise movement. This is anti-clockwise. So for equilibrium of force, anti-clockwise movement also equal to the clockwise movement. So they ask what is the distance of x? How can we calculate x? Here it is question 2. We know the B and downward force, it is 9 Newton. Then we don't know the distance between center to B. So this is clockwise movement. Then it is equal to anti-clockwise. We already find out it is 4.5 Newton meter. Okay. Is that clear, student? This uniform beam AB kept in equilibrium point, so that's why clockwise movement equal to the anti-clockwise movement. So we have to find out the x value. So then how can we calculate? Here, what is the answer? X value?
0.5 meters.
Yes, very
50
good.
centimeters.
0.5 meters.
Teacher, it
Here,
should be centimeters, right?
0.5 meters. Okay, is that clear, student? Clockwise movement is equal to the anti-clockwise movement, so we have to find out x value. It is 0.5 meter. So another question. If the weight of the rod is 2 Newton, calculate the total weight acts on point B. Total weight, if the weight of the rod is 2 N, if the rod is 2 Newton, what is the total weight act on point B? Can you tell me?
We should add the total downward force at B, then the weight plus the weight, and finally the weight of the rod. Then only we get the answer.
Yes, it is B and it is 9 Newton for downward plus they given us weight of the rod is 2 Newton. That's why sum of the total weight is how much? 11 Newton. Okay, is that clear, student?
Yes, teacher.
Yes, okay, very good. Then C part, we will move on to the another part. Here, C, an uniform rod AB is clamped at the point X as shown in the following. Here, A and B clamped at the point X as shown in the following. Here, A to center, it is 0.3 meter. Then center to B, 0.2 meter. Then first question they ask, What is the magnitude of the force that should be exerted on point A? What is the magnitude of the force should be exerted on point A? At point B, can you tell me? What is the magnitude of force that should be exerted on point A?
6.6 Newton.
15
Point,
Newton.
point A. Here, carefully read the question, my dear. It is uniform rod AB is clamped at the point X. So, one point is B and it is downward Newton force. So, that's why they ask what is the force of AN. So, for it is on equilibrium uniform. It is an uniform rod in equilibrium form. A force also 10 Newton because it is on equilibrium. A force also 10 Newton, but direction is opposite. 10 Newton. B end is upward one direction. Other end it is also 10 Newton for upward. Sorry, this is downward. Other end upward. So A force is 10 Newton. Okay. For equilibrium force, A end also 10 Newton. They ask then which direction that force should be exerted. Direction. For equilibrium of that uniform beam, if the one end also up downward 10 Newton, the other end also 10 Newton, it is should be upward. Direction is upward. So then another question they ask, what the moment of the couple of force acting on the rod? So I think you all remember what is the formula of moment. Moment equal F multiplied by D. So can you calculate the moment of force? Can you calculate it? What is the moment couple of force acting on the rod? What is the F? What is F?
Force.
10 Newton.
Yes. It is 10 Newton. Distance. Here, look at the diagram. Distance, they given us, there are two distance, A to center and center to B. It is sum of 0.3 plus 0.2. So that's why distance is how much?
0.7.
6 meter. 0.3 plus 0.2. Sorry, 5.
5.
What is the answer? Here moment is 5 Newton meter. Is that clear, student? Can you the D part by yourself? Is it already done? Okay, we will go to another part, D part. In D part, 12-meter uniform rod AB was suspended from the center. It was maintained at equilibrium by suspending weights as shown below. Here,
Excuse me, teacher.
carefully. Yes.
Teacher, in the first question, Fourth one, when we calculated the couple of forces, we only considered one part of it, right? Then why in the third question we considered the whole?
For moment, you ask a moment of the couple of force.
Yeah, for the couple of forces.
Uniform rod of AB is clamped at the point X. Therefore, distance we have to calculate as sum of the A to center. Here, this is they given as point clamped at the point X. Okay. Okay. In D, 12-meter uniform rod AB was suspended from the center. First question there, what is the anticlockwise movement due to the 10 Newton force? You already know the formula of movement. How can we calculate the movement? Anticlockwise movement? How can we calculate anticlockwise? They ask movement due to the 10 Newton.
6
How
Newton.
can? Yes. Force is 10 Newton, then multiplied by what is the distance? Distance A to center. It is
0.6.
0.6. 0.6. So what is the anti-clockwise movement due to the 10 Newton force is formula of movement is movement equal F multiplied by D. F mean 10 Newton multiplied by then distance 0.6 because A to center it is 0.6 meter. Is it clear?
Yes, teacher.
Yes. Okay. Then the other part. What is the anticlockwise movement due to? 7.5. 7.5. What is the answer?
3 Newton. 3 Newton.
Yes, 7.5 Newton. What is the distance? It is
0.4.
yes, 0.4. What is the answer?
3 Newton.
It is 7.5 Newton moment. It is anticlockwise moment. Answer is sorry 30 Newton meter. 30 Newton meter moment. So, my dear children, always remember all the formulas in your textbooks for chemistry and physics part. So, that's why you will be able to do the calculation part immediately. Remember all the formulas in your textbook, okay? So, we all know the formula of movement. Then, third question they ask, what is the total anticlockwise moment of force? Total anticlockwise moment. Here, look at the diagram, student. They ask total anticlockwise moment. So we already find out anticlockwise moment of 10 Newton is also 10 Newton for A end it is 40 Newton. Then C point it is 45 Newton force. It is find out anticlockwise moment is 30 Newton meter. So what is the total anticlockwise moment? How can we calculate total anticlockwise moment?
3 Newton meter plus 6 Newton meter.
Yes.
Teacher,
For
Teacher,
yes.
then 13 Newton meters.
teacher, that
Yes.
should be changed then.
Yeah, it should be 3 Newton meter, not 30.
It should be 3, teacher.
755 by 0.4.
3 Newton meter.
Yes. 3 Newton meter. Yes. What is the answer?
3 plus 6, 9 Newton meter for third one.
Third one. What is the answer? M. What is the total anticlockwise moment? For D. Total anticlockwise moment is how much?
9
9 Newton meter.
Sorry, this is my mistake. Okay. Here this is 3 Newton meter. Sorry for that. Here F multiplied by D, then 3 Newton meter. Okay, they ask anticlockwise, total anticlockwise moment. First, we calculate it is as 6 Newton. Then the 7.5 Newton force anticlockwise we find out as 3 Newton meter. So total anticlockwise moment how much? It is 6 Newton meter plus 3 Newton meter. So what is the answer? 9 Newton meter. Okay. Fourth question, they asked the rod is maintained an equilibrium by the force X suspended from point B. What is the value of X? What is the value of X? So you all know for equilibrium point, equilibrium of force, anti-clockwise movement equal to the clockwise movement. So that's why we have to calculate, we have to find out X value. We don't know the X value for Bn. So how can we calculate it? Fourth question.
15 Newton.
Yes.
$15 newtons.
Yes, 50 Newton means we all find out the total movement. It is 9 Newton meter. Then we don't know the X value. Then what is the distance between? Here it is 0.6. What is the answer?
15 Newton.
Yes. So this is a 1 decimal point. We can answer is 15. Sorry. 15 meter. We calculate from 10 to eliminate decimal point. M is 15 meter. Is that clear?
It's 15 newtons, right?
15 Newton, teacher.
Sorry. Yes. Yeah, sorry. It is 15 Newton for the other end. It is H value is 15 Newton. Okay. Then there are two anti-clockwise movement we already calculated. This is H value is 15 Newton. Okay. Then question number 2. It is also regarding equilibrium of force question. Here, question number 2. A light uniform plank is suspended from its center and it is in equilibrium. That is also in equilibrium. A bucket of sand of mass 4 kg is suspended at point 0.75 meter from the center on one side of the plank. A stone is suspended at point 1.5 meter from the center on the other side of the plank. Here they ask find the weight of the bucket of sand. How can we calculate weight of the bucket of How can we calculate the bucket of sand? Weight of the bucket of sand. Here they given us mass is 4 kg. Distance 0.75 meter from end to center. Other distance 1.5 meter to the other end. How can we calculate weight of the bucket of sand? What is the formula we can use?
Mass in gravity.
Mass into gravitational acceleration.
Yes, weight of the bucket. We can use this formula. Here we have to calculate weight of the bucket. They already given us it is as how much it is? 4 kg. What is G?
10.
Yes, 10. What is the answer?
40 Newton.
Yes, this is the weight of bucket of sand. Then what is the other
Teacher,
question? Yes.
it should be 40, not 400.
Not yes, it's 40. 40 Newton, okay? Then second question, what they ask? Find the anticlockwise movement due to the bucket of sand. Anticlockwise movement. Can you calculate it? Anticlockwise movement? Movement equal F D. What is F?
40.
Yes, we all
0.75.
already find out it is 40 Newton. Distance, how much?
0.75.
Yes, 0.75. What is the answer? Anticlockwise movement.
30 Newton.
30
30 Newton meter. That is the answer for anticlockwise movement. That is the answer. 30 Newton meter. Okay. Finally, they ask find the mass of stone. How can we calculate mass of stone?
Find the force acting on it, then we can divide it by gravitational acceleration to find its mass.
Yes. So, shall we erase? Shall I erase?
Okay, teacher.
Okay. Here they ask mass of stone. Here you all know mass of equilibrium of moment. It is equal to clockwise moment. So we already calculate it as 30 Newton meter. So we have to calculate mass of stone. Mg. What is the distance? 1.5 meter. We don't know the m, g, 10. What is the answer?
20 Newton, that becomes 2 kilogram.
Yes. It is then after multiplication it is 15 then cut into, then what is the answer? 2 kg. Stone, what is the answer for m? It is 2 kg. For the equilibrium of that activity, they ask mass of stone. So that is m is 2 kg. Is that clear, student?
Yes, teacher.
Okay. Then question number 3. Question number 3. We will move to our paper. A tall cuboidal block of wood of mass 800 gram was placed on a horizontal table. Okay. Here, this is the figure. First, they ask calculate the weight of this block of wood. Calculate the weight of block of wood. This is also same. This is also same equation earlier that we have used. They ask first weight of the block of wood. How can we calculate? Formula is same formula. W equal mg. They ask weight of this block of wood. Consider acceleration due to gravity is 10 ms minus 2. So, third question first. Calculate the weight of W equal mg. So, what is m? What is m?
0.8.
Yes, they given us as gram. So, we have to convert it into the kilograms. So, it is 0.8 kilogram. Then 10. Answer is, what is the answer?
8 Newton.
Not 10.
8 Newton. So another question, weight of this block of wood is 8 Newton. Another question they ask, force exerted by the block of wood. The force exerted by the block of wood on the table is to the weight of the block of wood. How much is the reaction exerted on the block of wood by the table? How much is the reaction exerted on the
8
table?
newtons.
8 Newton.
Yes, it is also 8 newtons since block is at rest on a table. The block is at rest because it is also 8 newton. So another question they ask. Name the Newton's law motion that is relevant to the phenomena. What is the Newton's law?
Third law.
Third law.
Yes, Newton third law. What is the Newton third law?
Like
Can
an opposite or equal and
yes.
opposite force exerted by the table on the block.
Yes, for every action there is an equal and opposite reaction. Yes, Newton's third law. I think all are remember all the Newton's law. Question number 2. What they ask? Of point A and B, which is suitable to apply a force in order to move? A and B, which is suitable to apply a force in order to move the block of wood horizontally on die table as shown in figure 1. My dear student, remember it produced less turning point. What is the point? What is the point?
B.
B.
So dear student, recorrect that force. It is not F. It is recorrect as X. This X recorrect as F. Then the A and B. This is X force for right side. That both are X. Then left side it is not X. It is recorrect as F. Okay. What is a suitable point? A and B. What is a suitable point?
B.
I guess it's A.
Point I know.
Suitable point to apply a force is point A. Here, point A is suitable point. Without toppling, we can move the wood block of wood. Reason, applying the force at the produce less turning effect. So the block moves horizontally without toppling. We can move the block without toppling. Produce less turning effect. So we can produce less turning effect from A point. So that's why we can move horizontally the wood block of wood carefully without toppling. Okay, understood?
Yes, teacher.
Okay. Then they asked reason for your answer. Applying the force that produce less we can produce less turning effect. That's why it is can move horizontally without toppling. Third question they ask of A and B above, Newton balance force connected to the suitable point. Suitable to apply a force. Newton balance force connect to suitable point and a gradually increasing horizontal force X was applied. The horizontal force F exerted on the block of wood was plotted against the force X. Then the graph shown in figure 2 was obtained. Look at the graph. Here, y-axis F Newton, the other x-axis also Newton. Then what they ask from this graph, by what name is the frictional force exerted on the block of wood known when force X exerted on it is 3 Newton.
Static frictional force.
Static friction.
Yes, very good. Static frictional force. What is the meaning of static frictional? What are the other forces in frictional? What are the other frictional forces?
Dynamic.
Limiting frictional force and dynamic frictional force. The other one is static frictional force. For that process, it is static frictional force. What is the reason?
Because that it prevents the stationary object from the starting to move when an external force is applied acting on the parallel to contact
Parallel.
surface.
Yes, very good. At x, it is 3 Newton has not starting move. At 3 Newton, not starting move. Then applied force is how much? 3 Newton. Then frictional force also 3 Newton. It is equal and opposite. 3 Newton. When 3 Newton at force, it is not move. Block the wood of block at in rest. It is at rest. Okay. So not start move. That is why it is static frictional force. That is the answer. Okay, it is static frictional force. Question number B. What is the limiting frictional force exerted on the block of wood is an indicated in the graph. What is the limiting frictional force? Here,
4.8 newtons.
yes, very good. At 3 Newton, it is at the block of wood at rest, didn't move. Then what happened in 4 Newton? 4 Newton force, it is start to move. Limiting frictional force is 4 Newton. Is that clear?
Yes, teacher.
Okay, very good. Then we will move on to the another question. They
So
ask,
isn't it about very fluid? Since they have
sorry,
asked the friction, we have to see the vertical column, right? Vertical y-axis.
y-axis.
Yeah. It's about 4.8 or something, right?
Yes, for y-axis it is, we can calculate it, we can gain it as a 4 Newton force. This is
But they
the
have asked the friction effects, right?
blue covered was plotted against force. Here, in 3 Newton force, it didn't move. At 4 force, it is starting to move. For another question, it is asked
What is the
for
limiting friction force? So we had to check that 4.8, that one, right?
limiting frictional force. It is 4 Newton. It is 4 Newton. Limiting frictional force, because a static frictional force, it is 3 Newton. It is starting to move on 4.8, no, 4 Newton.
Okay, teach, thank you.
Then question number 4. It was required to drag a large block of wood along rough, flat surface. State 2 different methods that can be used. Reduce friction. What are the strategies we can use to reduce friction? You all know what is the meaning of friction. There are 3 frictional forces: static, limiting, and dynamic. Then how can we reduce the friction?
Polishing the surface and apply liquid.
Yes, we can apply oil or use rollers or wheels. That's why we can reduce the frictional force. Is that clear? Yes. Question number 5. Mass of the block of wood mentioned in above is 200 kg. Calculate the acceleration of the block of wood in the force when an unbalanced force of 100 Newton is applied. What is the answer? Mass of the block of wood mentioned above is 200 kg. Calculate the acceleration of the block of wood. How can we calculate it? Mass is 200 kg. So unbalanced force is how much? 100 Newton. So we have to calculate.
F equal M.
What is the formula we can use? F equal MA. So we have to calculate. They ask acceleration. They ask acceleration. So A equal. What is F?
100 Newton.
100.
100 Newton. What is M?
200 kilogram.
Yes. 200 kilogram. What is the answer?
0.5.
What is the answer?
0.5 meter second minus 2.
Yes. 0 point. Acceleration. This situation explained by what is the Newton's law? What is the Newton's law? This situation explained by.
Second.
This situation is
Second law of motion.
yes, Newton's second law of motion. Acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Remember all the Newton's law. In that session, it is regarding Newton's second law. F equal ma. That is the formula. Okay. Another question. What they ask? What is the other one? The block of wood moved through a distance of 4 meters under the unbalanced force applied as above. How much is the effective work done in this motion? What is work done?
400 joules.
Yes.
400 joules. F E.
Work done. What is F?
100 Newton.
$400 joule. It is 400 joule. Okay. Work done. F multiplied by D. 100 Newton multiplied by 4. Then 400 joule. Is that clear? Okay. Another question. Fourth question. Shall I rest?
Okay, teacher.
Okay, we will move on to the another question. Fourth question. A turning effect can be made by applying a force on an object. The force applied for this depends on the distance from the hinge axis of rotation to the line of the action of force. There are 2 points A, B and C. It is hinge axis of rotation to the line. First question they asked, this diagram shows 3 places where force is applied to turn a door, 3 places where force is applied to turn a door. What is the point to which a higher force should be applied to turn the door, not 10, to turn the door? What is the point to which a higher force should be applied to turn the door?
C.
C.
Is
C.
that
C.
P or what is the answer?
Point C.
Which a higher force should be applied? There's higher force. Force is applied to turn a door. What is the point to which higher force should be applied? Force, it is answer is point A. Because to get a large turning effect, we can get a large turning effect. They ask a higher force should be applied to turn the door. Higher force. Yes, higher force should be applied to turn the door is C. Answer is C. Yes, to get a large turning effect, it is C. Second question, the distance from the rotational axis of two hinges to the point A is, it is 90 centimeter if the minimum force to turn the door from the point is 5 Newton. Calculate the moment of the force when turning the door. Can you tell me the answer for moment about the hinge point A? So we'll calculate the moment.
4.5.
4.5 Newton meter.
Yes, distance. What is D?
D is 0.9.
What is D? It is 0.9 meter. What is for F?
5
It is,
Newton.
yes, it is 5 Newton. So moment due to a force. What is the answer?
4.5 Newton meter.
Yes, 4.5 Newton meter. That is the answer. Third question, there's minimum force at point B. Now, movement of the force at point A is 4.5 Newton meter. We calculate that. They ask if the distance from axis of rotation to the point B is 45 centimeter. Calculate the minimum force should be applied to turn the door from the point B.
10 Newton.
What is the answer?
10 Newton.
Yes, 10 Newton. Distance at B, it is how much? 0.5 meter. Moment, they ask force. So we can calculate force. Moment divided by distance. So what is moment? We already find out what is moment.
4.5.
Yes, moment was 4.5. Distance
0.45.
0.45. So we have to eliminate decimal points. What is the answer?
10 Newton.
That is the answer. Distance at B is 0.45 meter. So we have to calculate force. It is equal moment divided by distance. Force is applied. It is 10 Newton. So it is 10 Newton. Fourth question. What is suitable place fixing a handle to open and close the door out of A, B and C point?
Point A.
Yes, very good. What is the reason? What is the reason?
Least of force.
It is a suitable point is point A. Reason is should be fixed far from the hinges, so require minimum force. It is require minimum force. At C point it is require large force. At A point it is required minimum force. Should be fixed far from the hinges, so they require minimum force. Is that clear?
Yes, teacher.
Yes. Okay. Here, look at question number 5. State whether couple of force creates or not in the following situations where moment of force is created. Here, state whether couple of force creates or not in the following situation where moment of force is created. Turning the pedal of a bicycle. Is that a couple of force? Turning a pedal of a bicycle?
Yes.
Yes.
Couple of force requires two equal and opposite forces. Turning a pedal of bicycle. Single force is applied to the pedal, creating a movement around the pedal axis. Single force is applied to the pedal, creating a movement around the pedal axis. So, what about B? Turning the handle of a bicycle with both hands.
It creates a force, teacher.
Yes, there are both hands. There are two forces typically applied in opposite direction on either side of the steering axis, forming a couple of force. That's why turning the handle of a bicycle with both hands, it is couple of force. What about C? Turning the steering wheel of vehicle with a single hand.
No.
No, yes, because couple of force need two equal coplanar in opposite direction. In third one, turning steering wheel with a single hand involves applying a single force, not couple of force. Okay. We can move on to the third B part. Another question. If an object rests when the forces are applied, external forces exerted on the object are said to be at an equilibrium. Following diagram shows such an instance. Here A and B rest when forces are applied, external force exerted on the object. It is an equilibrium. First question, they ask, write 3 requirements to be fulfilled to remain the rope at rest. What are the requirements? For it is in equilibrium. What are the requirement for equilibrium force? It is an equilibrium.
Force exerted by A and B along the same must be equal in magnitude, and the force must act on the opposite directions along with the same line of action, and finally the resultant force acting on the rope must be zero.
Must be 0, yes. All forces must be, vector sum of all forces must be 0. Sum of all clockwise movement about any point must be equal to the sum of all anticlockwise movement. Okay, is that clear?
Yes, teacher.
All forces must be 0, then must equal the sum of all anticlockwise movement for all clockwise movement for the equilibrium for that instance. Another question they ask, if the resultant force exerted by the inside A is 1500 Newton and all the people inside B exerted equal force, they ask in A question, what is the resultant force exerted by people in the side B? If the F side B is equal to the another side B, what is the answer? What is the answer? They ask, what is the resultant force exerted by the people in the side B? If A is 1500 Newton, what about B?
B is also the same thing, teacher.
Yes, because it is in equilibrium, it is at rest in equilibrium. So B also 1500 Newton. A side B equal to the B side. Okay, A equal B. A is they given us to 1500 Newton. So that is why B also 1500 Newton. What is the force exerted by a person in the side B? Person in side B. Count the number of people inside B. Count the number of people inside B. Here 1, 2, 3, 4, 5. There are 5 people in side B. By observing the image, there are 3, 4, 5. There are 5 people. So how can we assume all people inside B exert equal forces? Assume all people inside B exert equal force. Okay, the force per person is the total force divided by the number of people. If what is the force exerted on side B? What is the force? 1000.
1500 Newton.
Yes, 1500 Newton force exerted by side B. There are 5 peoples inside B. So we can assume that assuming all people inside side B exert equal force. So we can they ask force exerted by a person, one person. So we can 1500 Newton divided by number of people 5. What is the answer?
300 Newton.
Yes, 300 Newton. Because we can assuming all people inside B exerted an equal force. The force per person is the total force. So F side B, we can divide it into N. N mean number of people inside B. There are 5 people. So after calculation, we can find out the force per one person. Okay, question number 3. The diagram shows, okay, we will do the Question number 3. Here, the diagram shows how a child is rest on a swing. This is a diagram. Here, the 300 Newton force one side and 300 Newton for other side. Question number A, they ask, what is the resultant force created on the swing? What is the resultant force? Can you tell me what is the resultant force exerted on swing? Resultant force?
Newtons.
0.
0.
Yes, very good. Resultant force created on swing is 0. What is the reason? This is because child is at rest, not moving. Child is at rest, indicating the upward tension force from the rope balance the downward force. Upward force balance for the downward force, because of resultant force must be 0. The child is at a rest. Okay. Question number B. What is the mass of the child? What is the mass of the child?
60 kilograms.
60 kilogram.
The child is at rest, so that total upward force, it is mean tension, it is how much? 300 Newton. For upward, downward force is what? Weight. We can calculate here. Total tension. $300 plus upward 300 and downward for 300, because it is at rest in equilibrium force. What is the answer? They ask total tension. Total tension, we already find out it is 600 Newton. So how can we calculate the mass? It is W equal mg. So we need to find out the mass. Weight is 6 Newton. G we already know, it is 10. What is the answer? Ten over 10. 60 kilograms. Here, mass, how much it is? 60 kilograms. Mass of the child is 60 kilograms. First, we have to calculate total tension, okay? Here, look at the diagram. One force is 300 Newton, another force also 300 Newton. So, child is in rest. We have to calculate total tension. Total tension, it is 300 Newton plus 300 Newton. Total tension of that child is how much? 600 Newtons. First, we have to calculate total tension. Then after we can calculate mass of the child. What is the equation? W equal mg. What is the answer? 60 kilogram. Mass of the child is 60 kilogram. Is that all? Understand, student? Okay. Is that clear, student? I hope end of the session you all are got perfect knowledge regarding science subject. Don't get stressed. First thing is you have to remember all the formulas in your lessons. Then in biology lessons you just read the lesson. Don't remember all the page by page. Just read the lesson and got the idea. Remember all of the thing as a summary. So always make short notes. I would like to say always keep your practicing all the past paper question, model paper, supportive question. Keep always being practicing. So that's why you will be able to get the perfect knowledge regarding science. Okay. Um, shall we move on to the another question? Can you hear me?
Already.
Okay. Fifth one. This is also same type of question. A jackfruit of mass 10 kg hanging from a branch. At a certain moment, it detaches from the stalk and take 2 seconds to fall to the ground. Acceleration due to gravity is 10 ms minus 2. They ask first question, explain why the jackfruit does not fall down while it is hanging with reference to the equilibrium force. What is the reason? Jackfruit does not fall down. What is the reason? Can you tell me what is the reason? Because upward force in the stalk is equal to the downward gravitational force. Here this is acceleration due to gravity is 10 ms minus 2. They ask explain why the jackfruit does not fall down while it is hanging. Because upward force is equal to the downward force. Because does not fall down. It is upward force in the stalk equal to the downward force, downward gravitational force. That's why this is balance of force. Keep the fruit in equilibrium. Is that clear or not? Upward force of upward force on a jackfruit equal to the downward gravitational force. So that's why it is in equilibrium force. Then question number 2. Draw a rough diagram jackfruit, mark the forces acting on it. Okay. I'll draw that. Draw a rough diagram. Here, tension, here, tension, weight. This is a rough diagram of jackfruit and forces acting on it. The jackfruit, it is in equilibrium point. It is at rest before falling to the ground. So upward force, tension is equal to the downward gravitational force. That is the rough diagram of it. Second question they ask, according to the mass of the jackfruit, what is the name of the force acting downward on the jackfruit?
Weight.
What is the name of the force? What is the name of the force? Can you tell me what is the name of the force for downward?
Weight.
It is gravitational force. Gravitational force or weight. According to the mass of the jackfruit, what is the name of the force acting on downward on the jackfruit is? It is gravitational force. It is for downward. It is gravitational force exerted on the jackfruit. Here, another question, find the magnitude of that force. How can we calculate magnitude of that force?
Mass into gravitational acceleration.
Yes. M G. What is M? It is 10 kg G 10. What is the answer?
100 Newton.
100 Newton. Do you understand jackfruit does not fall down while it is hanging? Downward force of gravity is balanced by equal opposite upward tension from branch. Is that clear? So that's why we can calculate magnitude of that force. Weight equal mass multiplied by g, then answer is 100 Newton. So another question they ask, find the resultant force acting on the jackfruit before it falls to the ground. What is the answer? Resultant force. What about resultant force? How much is that? Resultant force? Because the jackfruit at rest, it is in equilibrium. It is hanging on at rest, equal and opposite, upward and downward. It is at rest. So what about the resultant force? It must be 0. Resultant force must be 0. Here, resultant force it must be 0. Can you understand? Because it is at rest. Here, look at the diagram. Upward tension and downward weight. Gravitational force and upward force tension, it is equal. So that's why always resultant force equal. Okay. It is must be 0. Tension subtract by weight, it is must be 0. Okay, then fifth question, they ask write two conditions that must be satisfied for the jackfruit to remain in equilibrium. The jackfruit remain in equilibrium force. What are the conditions that must be satisfied? What are the conditions? Can you tell me what are the conditions?
Both force should be equal.
Yes. Clockwise must be
Acting
equal to the
opposite
anticlockwise movement. Yes. Resultant force also 0. And clockwise movement equal to the anticlockwise movement. Then net moment on it must be 0. That's why it is jackfruit to remain in equilibrium. Okay. Is that clear? I will tell again. Net moment on it must be 0. Clockwise movement equal to the anticlockwise movement. It is and clockwise must be equal to the anticlockwise movement. Tension equal to the weight. Moment on it must be 0. That's why jackfruit to remain in equilibrium. Okay. Sixth question. Can you do that? Draw velocity time graph to illustrate the motion. Can you draw? Have you all complete the diagram? Have you all drawn diagram? Velocity time graph illustrate to motion of jackfruit. Jackfruit start from rest. It freely falls under gravity. Here, velocity time. Here, jackfruit start from rest. Jackfruit start from rest. Then it is freely falls under gravity. So it must be straight line. Okay, is that clear? Jackfruit start from rest. It freely falls under gravity. So the velocity time graph, the line should be straight line. Okay. Question number B. They ask what conclusion can you draw the shape of graph? It is in uniform acceleration. Is that clear? It is start from rest. Then it is going on uniform acceleration in velocity time graph. That is the conclusion. Uniform acceleration. Okay. Is that clear? Another question. The jackfruit takes 2 seconds to fall to the ground. Jackfruit start from rest. Freely falls under gravity. They ask. Jackfruit takes 2 seconds. Fall to the ground. Calculate the height from which the jackfruit falls. Calculate the height. How can we calculate the height? How can we calculate the height from which the jackfruit falls? Then after part B, they ask find the velocity of jackfruit just before it reaches the ground. Okay, I will explain one by one. Okay. Shall I erase? Question what they ask? Calculate the height from which the jackfruit falls. Then another part, find the velocity of the jackfruit just before it reaches to the ground. So, mass of jackfruit they given as M was 10 kg. So, acceleration due to gravity, how much acceleration due to gravity? 10 ms minus 2. So, what is the other thing they given? Time. Time to fold the jackfruit, it is taken 2 seconds. That are the information that they have given. Then ask, when the jackfruit is hanging, it has gravitational potential energy, no kinetic energy, okay? When the jackfruit is hanging, there is hanging, it has gravitational potential energy, no, there is kinetic energy, okay? Just before reaching the ground, potential energy becomes 0. Just before reaching the ground, potential energy becomes 0. Potential energy converted into kinetic energy. Okay, I will tell again. When the jackfruit is hanging, it has gravitational potential energy, no kinetic energy. Just before reaching to the ground, potential energy becomes 0. Potential energy converted into the kinetic energy. So, these are the information they have given. So, for find out the height and velocity, we use the principle. We can use potential energy. What is the formula of potential energy? mgh. I thought you all are remember all the formulas. Potential energy formula is potential energy equal mgh. M mean mass, G mean gravitational acceleration, H mean height. Then first we need potential energy, it is mgh. Then we need kinetic half mv square. Okay. These are the two principles that we use for calculating the height and velocity. Here, carefully understand P equal mgh, kinetic energy equal half m v squared. Okay, that is the principle we used. Okay, that is the principle we use for that calculation part. Here, this is then after equate of potential energy equal to the kinetic energy. Then another principle is we use equate of potential energy equal to the kinetic energy. Okay. Then what is potential energy? It is mgh. Then kinetic energy half mv squared. Here we can cut into m to m, gh half v squared. Then carefully understand principle of that we use for this equation. PE equal to KE, potential energy equal to the kinetic energy. So that's why that is the formula of potential energy. This is the formula of kinetic energy. We can cut into m to m. The GH equal half V squared. Then from motion under gravity. This is we can mark as 1. Then Here another one from motion under gravity. From motion under gravity, we can find we can use this formula to find out velocity. We already know G mean 10 ms minus 2, time taken 2 seconds, velocity is 20. Here this is motion under gravity, velocity is 20 meter per second. This is the formula of 2. Here this is the formula that we this is the first formula that we can use. This is the another one to find out velocity. It is 20 meter per second. So then we already find out the velocity. Then after we have to calculate the height. So for the calculation of height, we can use this formula. So we can simplify this formula to find out the height. We can use GH we know the G, it is 10. We don't know the H, half 20 ms. We already find out the velocity. What is the answer? What is the answer? We can H equal 20 meters. Is that clear, student? If you have any doubts, you can ask from me. Okay? Student, do you have any doubts? I will tell again. Mass of the jackfruit is 10 kilogram. Acceleration due to gravity is 10 ms minus 2. Time taken 2 seconds. So we can use that principle. We already know the potential energy formula and kinetic energy formula. This is the principle that we used. Then after, equate of potential energy equal to the kinetic energy. That is the formula. mgh equal to the half mv squared. Then after we find out first formula, gh equal half v squared. Then they ask question number B, motion velocity. So that we have to calculate motion under gravity from using this formula V equal GT. So G mean 10 ms minus 2 plus time taken 2 seconds. Answer is 20 ms minus 1 velocity from motion under gravity. So that's why A question they ask height. So that's why we can use this formula to find out the H. H is 20 meter. Then velocity before reaching the ground, how much is that? Then velocity before reaching to the ground. How much is that? We can take it as mgh equal m, we already know 10, g also 10, h we already find out the h value, it is 20 meter. 20 meter equal 10, we don't know. Then v, what is the answer? 2000. Then v squared, it is 20. Don't get complicated, student. It is okay. Sorry.
திடீர்னு சொல்லுவோம் திடீர்னு அவன் செய்தேன்னு கொண்டு செய்தான்
You can't see the board?
யார் கடையில இப்ப லோவர் கிட்ட வார சரி பரவாயில்ல சார் சொல்லி கடையில யாரு இப்ப
If you have any doubts, you can ask me.
ரிசல்ட் கேட்க அவனுக்கும் சொல்லிங்க கிளாஸ் வேற
Okay. Height in 7th question, part A, calculate the height from which the jackfruit flows. That is the first formula we used. Principle of that we used is potential energy equal to the kinetic energy. So that is what we first find out the formula. Then it is we calculate the we can calculate the velocity from this formula. Then after we calculate height from which the jackfruit falls. This is also velocity before reaching to the ground. mgh equal to the half mv squared. That is also the same way find out the velocity. Velocity of jackfruit just before it reaches to the ground. Before it reaching to the ground, that is the velocity, it is 20 ms minus 1. 20 ms minus 1. If you want to write down the things, write down as a short note or something. Shall I erase or not? Student, can you hear me? We will move to the question number 6. Question number 6. Here, student, is that clear, student, this equation part? If you have any doubts, you can ask me. Okay, I will move on to the another question. Sixth question. A ball was thrown upwards with the velocity 20 ms minus 1. Gravitational force is 10 ms minus 2. Calculate the time taken for the ball to reach the maximum height. How can we calculate maximum height on it? Ball was thrown upward with velocity of 20 ms minus 1. There's time taken for the ball to reach the maximum height. How can we calculate it? Okay. What is the question they ask? Ball was thrown upward with velocity 20 ms minus 1. Calculate time taken for the ball. So, acceleration, first we have to calculate final velocity subtract by initial velocity. First we have to calculate final velocity subtract initial velocity, time taken to reach maximum height. So acceleration equal v final velocity subtract by v initial velocity divided by time. Okay, what is the final velocity? Ball was thrown upward with velocity of 20 ms minus 1. So that's why initial velocity, how much is that? Initial velocity?
0.
What is the final velocity and what is the initial velocity? And what is the time taken? What is the final velocity? It is 0. Initial velocity 20. What is the time taken? Uh, can we do the calculation from using this part? Thrown upward at velocity 20 ms minus to calculate time taken. Here, how can we calculate the time taken? T equal Vf, then initial velocity we don't know the time. Final velocity is 0. Subtract by initial velocity, it is 20 ms minus 1. What is the gravitational acceleration? It is 10. What is the answer? What is the answer, student? Minus 20. Time taken, it is 2 seconds. That is the answer. Here, they ask, first they ask, calculate the maximum. They ask, calculate time taken for the ball to reach the maximum height. So we have to first calculate what is the formula that we used. Acceleration equal the final velocity subtract by initial velocity divided by time. So we don't know the time, so that's why T equal final velocity subtract by initial velocity, then divided by acceleration, gravitational acceleration, it is 10. Then after, what is the answer? Time taken for thrown upward with the time taken thrown upward, it is 2 seconds. Time taken to reach maximum height is 2 seconds. Then another question they ask, find the maximum displacement of the ball. What is the formula to find out displacement of the ball? Displacement equal mean velocity multiplied by time. I think you all are remember the formula. Displacement equal mean velocity divided by time. This is first one. Displacement mean velocity divided by time. So, what is mean velocity? What is the mean velocity? Here, mean velocity. Final velocity, it is 0. plus initial velocity, it is 20. We can divide it into 2. What is the answer? What is the answer? Sorry. Mean velocity multiplied by time. That is the formula. Displacement equal mean velocity multiplied by time. So we know the mean velocity in final velocity 0. Then after initial velocity is 20 ms minus 1. What is the time taken? 2 seconds. What is the answer? What is the answer? Here, 2 seconds. Answer is 20 meters. That is the answer. That is the formula of displacement equal mean velocity multiplied by time. Displacement equal mean velocity multiplied by time. That is the formula. So then third question they asked, draw the velocity time graph for the motion of the ball from the time it was thrown upward until reach the ground again. Carefully listen the question. Velocity time graph for the motion of the ball from the time it was thrown upward until it reached the ground. Okay. I think you all are write down the equation parts. Isn't it, my dear student? Am I audible?
Yes, teacher.
Okay. I'll erase. Okay. Then we will draw velocity time graph. Okay. Velocity time. Here, thrown up until it reaches the ground. Again, initial velocity it is 20. It is start initial velocity 20. So rest. Time taken were 2 seconds. Initial velocity it is 20 ms minus 1. Time taken was 2 seconds. It is like that. Initial velocity 20 ms minus 1. Time taken were 2 seconds. As you know, initially it has start from 20 ms minus 1. By the end of 2 seconds, it has come into 0. After 2 seconds, it has come into 0. Initial velocity, it is 20 ms minus 1. Start from 20. Then after 2 seconds, it is come into rest. Then by the end of 2 seconds, it has come to 0 and again it has reached the velocity of minus 20. Here it is reaches to minus 20. Can you all understand? As you know, initially it has start from thrown up until it reached the ground. Again, initial velocity it is 20 ms minus 1. Then time taken were 2 seconds. Then as you know, initially it has starts from 20 ms minus 1. By the end of the 2 second, it is come into the rest. After 2 second, it is come into the rest. Come to 0, and again it has reached velocity of minus 20 ms minus 1 in another 2 seconds. Okay. Initially it has start from 20 ms minus 1. Then by the end of it is 2 second it has come to 0. Then after another 2 seconds, again it has reached velocity. It is minus velocity. Okay, it is minus 20 ms minus 20 ms minus 1 in another 2 seconds. Okay, I think you keep on practicing all the calculation parts, then you will be able to get a better knowledge. Then you can do the calculation parts immediately. So we already do there are 6 questions. Then before move on to the 7th question, shall we get a break? Then after we will continue from 7th question. Okay, student?
Teacher, break is for how many minutes?
20 minutes?
Okay.
Okay. Okay, student. Shall we start? Okay, shall we start? Because we have a limited time. We have a time issue. So, shall we start from 7th question? Here, can you hear me?
Yes, teacher.
Okay. Okay. 7th question. Group of students carried out an activity to determine the energy change of the reaction between sodium hydroxide solution and hydrochloric acid solution. They use following material for the activity. 50 centimeter cubes of 2 mole per decimeter cube NaOH, 50 centimeter cubes of 2 mole per decimeter cube HCl solution, 2 beakers, thermometer, glass rod and styrofoam cup. Draw a diagram to illustrate the activity. Can you draw the diagram? What they used? They use styrofoam cup, then use a styro thermometer, thermometer, styro. This is styrofoam cup, thermometer. What is a mixture? NaOH plus HCl. NaOH plus HCl. This is the solution. This is the diagram that illustrate. Second question they asked, write the balanced chemical equation for the reaction between sodium hydroxide and hydrochloric acid. Can you write the balanced chemical equation? Here they use what is the solution? NaOH aqueous plus mixed with HCl aqueous, then produce what they produce? Sodium chloride aqueous plus what is the other product? Sodium chloride plus H2O. This is the balanced chemical equation. There are two solution they use NaOH aqueous plus HCl aqueous, then produce sodium chloride and H2O. Then third question they ask, write two glassware used to measure the volume of solution. Can you tell me two glassware to measure the solution, used to measure the volume of solution? You can use measuring cylinder as well as pipette. Two glassware measuring cylinder as well as pipette you can use for measure the solution. Okay. Then fourth question they ask, calculate the number of moles of NaOH present in the solution used for the activity. They ask Number of moles. How can we calculate number of moles? What is the equation? Here you all know. How can we calculate the moles? What is the formula? What is the
So
formula? Yes. Question number 4. Moles equal CV. What is C? Concentration. V mean volume. N mean moles of NaOH. We have to calculate moles of NaOH. Okay. How can we calculate? N equal CV. What is the concentration of sodium hydroxide? What is the
Teacher, now
concentration?
you are drawing the activity.
Here, what you said?
Teacher, are you drawing the activity now?
Okay. Uh, number of moles of sodium hydroxide, this is the formula is N equals CV. So, first we have to calculate what is the concentration of sodium hydroxide. What is the concentration? Here, N equal concentration 2 mole per decimeter cube. What is the volume? What is the volume that they taken? It is 50 centimeter cubes. So it is, we have to convert it into decimeter cubes. Centimeter cubes, we have to convert it into decimeter cubes. So we can cut into decimeter cube into decimeter cube. 0 to 0. 2 mole. What is the answer? What is the answer? How much is that moles? 0.1 mole.
1 mole.
Yes, that is the answer. From that question, what is the formula that we used? N equal CV. That is the formula that we have used. N mean moles of sodium hydroxide solution. C mean, what is C? It is concentration of sodium hydroxide. V mean volume that we have used. It is given as in centimeter cube. So that's why we have to convert it into decimeter cubes. Then after moles of sodium hydroxide, it is 0.1 mole. Okay. Then fifth question, they asked, write 3 assumptions used by the students for the calculation of the heat changes of the reaction. Write 3 assumptions. Can you tell me the assumption that we have taken?
there is
We
no
can,
there is
yes,
no heat loss in the surroundings of the styrofoam cup, and the
yes,
density of the solution is the same as it's that the pure water.
water, yes. We can assume that density of solution is equal to the density of water. Okay, this is one assumption. So then we can assume that specific heat capacity of solution equal to the water. Specific heat capacity of solution, it is equal to the water, as well as density of the solution also equal to the water. There are two assumptions that we have taken to in this activity. Is that clear, student? Okay. Then we can draw a suitable energy level diagram to represent the reaction between sodium hydroxide solution and hydrochloric acid solution.
Teacher, what are the three assumptions? I just only heard one.
First one, specific heat capacity of solution, it is equal to the specific heat capacity of water. Okay.
Okay.
Then another one we can take as density of solution, it is equal to the density of water.
Ah,
Is that clear?
yeah.
Okay. Then we can draw a suitable energy diagram. My dear student, have you write down this?
Yes,
Shall I
teacher.
read?
Yes, teacher.
Okay. Shall we draw suitable energy level diagram? Okay. This is a question regarding heat changes associated with chemical reaction. It's your lesson. I think you all are remember that lesson. Here I will draw the energy level diagram. What are the reactants we taken? NaOH plus HCl. What are the products? Sodium chloride plus H2O. Can you tell me, is that which type of reaction? Energy is released or absorption? This is what is the reaction type? There are two types of energy chemical reactions. Can you remember? From that equation, reactants are NaOH plus HCl, so products are in sodium chloride plus H2O. Then from this reaction, it is
Exothermic.
release heat. Release heat. That's why it is exothermic. It is exothermic. This is an exothermic reaction. Reaction on top, NaOH plus HCl, it is release heat, then produce sodium chloride plus H2O. It is exothermic reaction. Can you remember what is another type of chemical reaction? What is exothermic? One is exothermic reaction. What is the other one?
Endothermic reaction.
Yes, endothermic reaction. What happened in endothermic reaction?
Heat is absorbed.
Yes, absorb. Heat absorbed in endothermic reaction. In exothermic reaction, release evolution of heat, release heat. So, I think you all are got the formulas and that chemical reaction. So, we will move on to the another question. So, first we will do ninth question. Okay, 8 and 9 question both are same type of question. 8 question you can do that at your home, yeah, because 8 and 9 it is same type of question. I will explain ninth question. Did you write the energy level diagram? Okay, we will move on to the another question. Ninth question. We will do ninth question. In increase of 100 Celsius in temperature was observed when 100 centimeter cubes of 2 mole per decimeter cube hydrochloric solution was mixed with 100 centimeter cubes of 2 mole per decimeter cube potassium hydroxide solution. Don't get stressed when you are reading the question. Carefully understand what they given. Increased temperature Celsius degree observed when 100 centimeter cubes of 2 mole per decimeter hydrochloric. Then it is mixed with 100 centimeter cubes of 2 mole per decimeter cube potassium hydroxide solution. That's it. There are number of moles of the reactants present in the solution separately. Now, I hope you all know the formula of calculation of moles. What is the formula? Number of moles equal concentration multiplied by volume. N equal CV. We will calculate it. They ask reactant present in the solution separate. Calculate the number of moles reactant present in the solution. So we have to calculate hydrochloric acid moles and moles of potassium hydroxide also. First we calculate moles of hydrochloric solution, moles of HCl. Moles of HCl. N equals CV. You already know this is the formula of find out the moles. Here C is concentration. What is the concentration of HCl? It is 2 mole per decimeter cubes. Then what is the concentration they given us? How much is that? 100 centimeter cubes. 100 centimeter cubes. So we have to calculate it into decimeter cubes. Decimeter cubes. So cut into decimeter. 2 mole. What is the answer? .2 mole. moles of HCl, it is 0.2 moles. Moles of HCl, it is N equals CV. C mean concentration of HCl, it is 2 mole per decimeter cube. Multiplied by volume, it is they given us as 100 centimeter cubes. We have to convert it into decimeter cubes. That's why it is divided by 1000. Then after answer is moles of HCl is 0.2 moles. Then we already calculate moles of HCl. Then we can calculate moles of potassium hydroxide. It is also same way because concentration are same. For the potassium hydroxide also 2 mole per decimeter cubes. Volume also same. It is given as 100 centimeter cubes. So that's why moles of potassium hydroxide also same answer. Can you understand what I am saying? Moles of HCl is 0.2 moles. Then they given us same concentration for potassium hydroxide also. Volume also same. That's why 0.2 moles per moles 0.2 moles of potassium hydroxide also. Student, then 8th question also same type of question. It is no need to repeat the same question. Have you all got the point, student?
Yes, teacher.
Okay. Then we will move on to the 10th question. The materials and equipment used to prepare 500 centimeter cubes of 1 mole per decimeter cube, a standard sodium chloride solution are shown in the figure. Name P and Q mentioned in the setup. Can you name here? Name this. It is as P. This is Q. They ask what is P and Q? What is P? It is wash glass. Sorry, wash bottle. P is wash bottle. Q is volumetric flask. Okay, is that clear? P is wash bottle. Q is volumetric flask. Wash bottle, or we can, it is a distilled water bottle. Then Q is volumetric flask. In second question they ask, name an instrument that can be to measure the mass of sodium chloride with watch glass in the preparation of above solution. Name an instrument that can be measure the mass of sodium chloride. What is the instrument? We can use electronic balance or beam balance to measure mass of sodium chloride watch glass in the preparation. We can use electronic balance as or beam balance. It is no need to write down in the whiteboard. You can write down. We can use electronic balance or beam balance. We can use to measure sodium chloride watch glass. Mass of the sodium chloride in watch glass. So, third question, what is the mass of sodium chloride required to prepare the solution? What is the mass of sodium chloride required? So, then we will calculate it. What is the mass of sodium chloride required? Volume. What is the volume? What is the volume? It is 500 centimeter cubes. Then concentration. Concentration, it is what? 1 mole per decimeter cube. Then molar mass. It is 58 5 gram. Third question, yes, what is the mass of sodium chloride required to prepare the solution? They given us molar mass of sodium chloride is 58.5 gram per mole. So, what is the equation that we use to moles of sodium chloride? It is N equal CV concentration 1 mole (500 centimeter cubes) converted into decimeter cubes. We can cut into what is the answer? (0.5 moles). So they ask, we find out the molar, we find out the moles of sodium chloride. Then they ask, first we find out moles of sodium chloride, but they ask what is the mass of sodium chloride. How can we find out the mass? Here, mass equal moles molar mass multiplied by molar mass. How much is the mole? 0.5 moles. What is molar mass? They already given 58. Gram per mole. We can cut. What is the answer? How much is that mass? How much is that? It is 29.5 grams. 29.5 grams. So that's it. They already given us volume. It is as 500 centimeter cubes. Then concentration given 1 mole per decimeter cube. Molar mass also given. First, we have to calculate moles of sodium chloride. It is N equals CV. First, we calculate the moles of sodium chloride. Then after we can calculate mass. This is the formula of calculation of mass equal moles multiplied by molar mass. Moles multiplied by molar mass. Then answer is 29.5 gram sodium chloride. Mass of sodium chloride required is 29.5
Teacher,
grams. Yes.
teacher, isn't it 29.25?
Answer. Is that incorrect?
It should be 29.25.
Yes, 29.25. Yes. Sorry. 29.25 grams. That is the answer. Okay, then ask what they ask. Fourth question. Should mass of sodium chloride on the watch glass flushed into apparatus Q from the bottom of the watch glass to the top or from the top to the bottom? What is the answer?
Bottom to top.
Top to the bottom or bottom to the top?
Bottom to top.
Top to
Because
bottom.
yes, top to bottom, because ensure all sodium, we need to ensure all the sodium chloride without losing. So to ensure all sodium chloride crystal completely transferred into flask without losing. Here, we need to transfer all the calcium, sodium chloride crystals without losing. It is suitable method is flushed into top to the bottom to ensure all sodium crystals completely transferred into a flask. It is need top to the bottom. That is the way. Then reason also ensure all sodium crystals completely transferred into the flask without loss. That is the reason for this answer. Then fifth question. Is that understood? What is the reason for it is flushed into top to the bottom? I think you all, is that clear? Then we will move on to the fifth question. The concentration of the prepared solution was observed to be less than 1 mole per decimeter cube. Concentration of prepared solution, it is to be less than 1 mole per decimeter cube. They are stated reason why the concentration getting less than expected value. Can you think? What is reason? Why the concentration getting less? So we think as when transferring sodium chloride crystals, it is not all sodium chloride crystal completely transferred into the volumetric glass. When transferring some sodium chloride crystals can be missed. No, all sodium chloride not completely transferred or dissolved in volumetric flask. Thereafter, it is less than 1. It is less than 1. Or some solution was lost during transferring, or when transferring sodium chloride crystal to volumetric glass, some solution was some crystals can be lost. Then after final observation, it is less than 1 mole per decimeter cube. Okay, that is the answer. Then another question. If sodium chloride crystals in the laboratory prepare the solution were contaminated with potassium chloride, what separation technique can be used to separate pure sodium crystals from them? Carefully read the question, student. It is a sodium chloride crystal contaminated with potassium chloride. What is the separation techniques can used separating solid by concentration solute that can turn into a solid in present in solution. We can separate solid. We can separating solid by concentration solution. Separating solid by concentration solute that can turn into a solid. Another question asks, example for practical application. Common salt from seawater. You all know common salt from seawater also separating solid by concentration solute. Separating solute by concentration separating solid by concentration the solute that can turn into a solid present in solution. Question B, answer is common salt from seawater. It is also separating solid by concentration solute. Okay. Then I think this activity regarding this activity in calculation parts, I think you all understand. I think you hope got the point what I am saying. So what are the formulas we have used for this equation? First one, N equals CV. First we have to calculate, we calculate molar mass of sodium chloride. Then formulation of find out the mass of the solution is mass equal moles multiplied by molar mass. This is one of formula. This is another formula. Always remember all the formulas in your lessons. Okay, that's why you can do the calculation parts immediately. Always doing past paper questions, model questions as well, supportive questions. So that's why you will be able to do a calculation part immediately, student. Okay. Then we will go to another. Eleven question. Here, look at the question. What is the question? Following is an apparatus used to react 100 centimeter cubes very dilute solution of NaOH with another centimeter cubes of very dilute solution of HCl. When NaOH and HCl solutions are mixed, the temperature change was 100 Celsius. So they already given specific capacity of water and density of water. This is the activity. These are the two solutions, NaOH plus HCl. This is, what is this? Then use thermometer, heat insulated aluminium vessel. That is the activity. Then first question they ask, is the temperature increase or decrease when NaOH and HCl are mixed? Is that increase or decrease? Student, carefully listen. It is undergoing the neutralization reaction. Mixing of NaOH with solution of diluted solution of HCl is undergo neutralization reaction. I will write down this. HCl and NaOH, it is undergoes with neutralization reaction. Here H plus ions released from H plus ion released from HCl. Then OH minus released from NaOH. H plus ions released from HCl solution, OH minus ion released from NaOH solution. That's why it is undergo a neutralize reaction, because heat release temperature of solution was increased because heat released temperature was increased. Okay, carefully understand. H plus ion released from HCl solution, OH minus ion released from NaOH solution, because heat released temperature of the solution was increased, because it is undergo neutralization reaction. Okay, remember those things. H plus ion released from HCl, OH minus ion released from NaOH. That is what heat released. Then after increase the temperature of the solution. Then second question they ask, according to the temperature change, is it an exothermic or endothermic reaction? You all got the point earlier. You have all know what is exothermic and endothermic. Regarding this activity, is that exothermic or endothermic reaction? Can you tell me? Is that exothermic or endothermic?
Exothermic.
Yes, very good. It is exothermic reaction. When chemical reaction happening, energy is released, evolution of heat. That is why it is exothermic reaction. In endothermic reaction, energy is absorbed. So in this activity, it is releasing energy. Okay, because heat released, then after temperature of the solution was increased. That is why it is called as exothermic reaction. Here, energy product releasing heat. In this reaction, releasing heat. Okay, it is exothermic reaction. Then third question, write the balanced chemical equation for the reaction NaOH and HCl indicating the physical state of reactants and products. You can do that. Balanced chemical equation. How can I write this? How can we write balanced chemical equation? Here. NaOH aqueous plus HCl aqueous plus what are the products? What are the products? NaOH plus HCl, sodium chloride plus NaOH plus HCl, products are sodium chloride plus H2O. This is the balanced chemical equation. Then another question they ask use of M in the apparatus. What can we use as M? Another question they ask.
Polystyrene,
Third question they ask balanced chemical equation. What is the use of M? They ask M.
to stir the reactants.
Here this is M. N is here. What is that instrument?
Stirrer.
It is thermometer used to measure the temperature of the solution. M is, it is thermometer here. What is we can use as M?
Stirrer.
Yes, very good. Stirrer. Thermometer here, this is stirrer. Then what is N? We can use,
Polystyrene,
yes, polystyrene. What is the reason of use polystyrene?
to
What is the
prevent
reason?
heat loss.
Yes, it is a heat insulator, prevent heat loss during this process. So that's why we can use polystyrene as N. Write an example for each exothermic and endothermic reaction take place in day-to-day life. Question number 6. Here. M relevant to the reaction we used styrer. Then material which can be used as N is styrofoam. Sorry, polystyrene. It is used as heat insulator. It is used because of prevent heat loss. Then other question is examples for exothermic and endothermic reaction. Can you tell me examples for exothermic and exothermic reaction? Example.
Exothermic reaction is used for combustion and endothermic reaction is
Yes.
for ice packs.
Yes. Then also endothermic photosynthesis also endothermic. So you can got Burning of fire, exothermic reaction, example for exothermic reaction, burning of firewood. Then use LP gas for cooking. Burning of firewood and LP gas used for cooking, it is, you can write down as exothermic reaction. For the endothermic, you can write photosynthesis, also absorb energy in green plant. Then we will move to the another question. If the NaOH and HCl solution used in the experiment have not labeled, briefly explain way of identifying those solutions. So, if the NaOH and HCl solution used in the experiment have not labeled, how we can identify those solutions? We can use litmus paper. So, NaOH, this is alkaline solution we use when after litmus paper, it is red color into, what is the color? Red color into blue color. Then HCl, it is acidic solution. We can use litmus paper. It is blue litmus paper into red color. That's why we can separately identify NaOH and HCl solutions. Here, look at the B part. It is also effective force related question. It is no need to repeat the question. It is same type of question. You can do that at your home. They ask mass of the weight, mat of the child, and resultant force. You all know how calculate resultant force. Then it is no need to repeat the question. And then we will move on to the another type of question number 12. Because there is limited time. So we will move to the 12th question. What is 12? A diagram of a blast furnace used for iron extraction is shown. Here, blast furnace, iron extraction shown. Carefully read the question. This is the blast furnace of extraction of iron. Okay. First question they ask. One component of the mixture entering from point A is it is hematite Fe2O3. Name the other two components. What are the other two components in there? We can use coke and limestone. Then other two components are coke and limestone. Here it is primarily as carbon, then limestone. CaCO3. Here we can use coke and limestone as the other components. It is carbon and limestone calcium carbonate. So these are the other two components we can use. Can you tell me what is the reason for use limestone? Calcium carbonate. What is the reason for using limestone and carbon? What is the reason? Coke is primarily carbon and act as both fuel and reducing agent in the blast furnace. It is act as a both fuel and reducing agent in the blast furnace. So then limestone also remove impurities. Limestone used to remove impurities. That is the reason to use for that blast furnace to that two components. Then second question they ask, why are fire clay bricks used to make B? Here this is B. They ask, why are fire clay bricks used to make B? What is the reason? Use fire clay bricks. What is the reason? Because they are heat resistant. We don't need to heat loss. So that's why B, they used fire clay bricks as heat resistant. Okay, write down the answer. Why are fire clay bricks used to make B? It is heat resistant. Write down the answer. It is heat resistant. Okay, third question. Temperature inside the blast furnace is higher than the temperature of the hot air entering through C. It is higher than. Temperature inside the blast furnace is higher than temperature of the hot air entering through C. They ask what is the reason. Here look at the diagram. Inside the blast furnace temperature it is higher than the temperature of the hot air entering through C. Here answer is because exothermic reaction happening inside the blast furnace. Because of exothermic reaction occur inside the blast furnace because releasing heat. That's why inside the temperature of the blast furnace is higher than entering through C. That is why it is exothermic reaction occur inside the blast furnace. That's why that is the reason. Here we can write down as we use carbon plus oxygen. Then make CO2. Then after CO2 plus carbon make 2CO, carbon monoxide. That is the further explanation regarding this answer. Exothermic reaction between hot air, it is oxygen. Exothermic reaction between carbon and oxygen make carbon dioxide. Then carbon dioxide react with carbon, then make carbon monoxide. 2 carbon monoxide. In exothermic reaction between the hot air and coke, it means carbon to produce carbon monoxide. Then heat temperature inside the blast furnace is higher than the entering through C. That is the further clarification for that. I think you can understand. Don't get stressed, student. Simply remember inside the blast furnace temperature is high because of it is exothermic reaction because heat released. That's it. Okay. Then question number 4. Name the material that are removed from location D and E. Location D and E. I think you can all remember this activity. I think it is in your textbook also. What is name for D and E? What are the materials that are removed from D and E? Slag from D and molten iron from E. Slag from D. It is molten iron from E. Slag from D and molten iron from E. Then the other one, carbon monoxide oxidizes hematite in iron ores. The corresponding balance chemical reaction is shown below. Here, carbon monoxides oxidize hematite in iron ores. The corresponding balance chemical. This is the balance chemical equation. Here, Fe2O3 react with 3 carbon monoxide. What are the products? 2 ferrous plus 3 carbon dioxide gas. Then this is the balance chemical equation. So they ask mixture of iron ore fed into the blast furnace. Blast furnace could produce 56 kilogram of iron. Calculate the mass of Fe2O3 contained in the iron ore mixed used here. Carefully read the question. So this is the blast furnace used to iron extraction process. This is blast furnace used to extraction of iron. Then they given us balance chemical equation. Then they given us mixture of iron fed into the blast furnace could produce 56 of iron. They produce 56 gram of iron. 56 gram of iron. Then they ask calculate the mass of hematite contained in the iron. They produce 56 kilogram of iron. They ask mass of Fe2O3 contained in the iron ore mixture. Okay, they given atomic mass unit of ferrous, oxygen and carbon also. Then I will calculate it. First, we have to find molar mass of hematite. Okay, find molar mass. First, we find molar mass. Okay. Fe2O3. How can we calculate it? They given plus 16 of atomic mass unit of oxygen. It is how much is that? Molar mass of hematite, molar mass of Fe2O3. It is 48. What is the answer? Molar. First, we have to calculate molar mass of Fe2O3. Then they given us atomic mass unit of ferrous, oxygen, and carbon. So that's why we already calculated molar mass of hematite. It is 160 gram. This is first step. Then we have to calculate, use the mole ratio from the equation. Use mole ratio. From mole ratio from equation. Here consider 1 mole of, here look at the balanced chemical equation. Dear student, look at the balanced chemical equation. First take Fe2O3 in balanced chemical equation. 1 mole of Fe2O3 produce 2 mole of ferrous. Look at the balanced chemical equation here. Here 1 mole of Fe2O3 hematite produce 2 mole of ferrous. Okay. Then one mole of Fe2O3 produce 2 mole ferrous. Okay. 1 mole of Fe2O3 produce 2 mole of ferrous. Look at the balanced chemical equation. So that's why if then after calculation we already know the atomic mass unit of ferrous, it is 56. It is 112 gram ferrous. 1 mole of Fe2O3 produce 2 mole of ferrous. So that's why we know the atomic mass unit of ferrous, it is 56. If it is 2 mole, it is multiplied by 2. Then after it, how much gram of the ferrous? It is 112 gram of ferrous. So we can say 160 gram Fe2O3 produce so that's the thing. From the mole ratio from the equation, 1 mole of hematite produce 2 mole of ferrous. We already know the atomic number 56. It is then after calculation it is 112 gram of ferrous. So we can say 160 gram of Fe2O3 produce 112 gram of ferrous. Okay, that's it. That is step 3. Then again read the question. A mixture of iron or fed into the blast furnace could produce 56 gram of iron. They given us they could produce 56. They could produce 56 gram of iron. So we have to calculate 56 kilograms into grams. Convert given iron produced 56 into given 56 kilograms into grams. It is 56,000 grams. Okay, then it is step 4. Okay, then after, what is the equation they ask? Calculate the mass of Fe2O3 contained in the iron mixture used here. Here, calculate the mass of ferrous. Sorry, Fe2O3, mass of Fe, mass of Fe2O3 using direct proportion. You can use Fe2O3. If we can say $56,000 gram. So don't get complicated, student. I will explain again this question here. Then the question asks calculate the mass of Fe2O3. This is the final step. This is the final statement. So mass of the Fe2O3 we can calculate. Fe2O3 equal, it is we already find out molar mass of Fe2O3, it is 160 gram. Then if 1 mole of Fe2O3 produce 2 mole of ferrous, that is why it is produced 112 gram ferrous. Okay, then we can say it 160 gram over 112 gram multiplied by then 56 gram. We can find out the mass of Fe2O3. What is the answer? Can you calculate it? Here, answer is that is the answer. Okay, carefully understand. This is 4 and this is here. This is step 2. This is 3 and this is 4. Here, look at the question again. Carbon monoxide oxidize hematite in iron ores corresponding balance chemical equation. Carefully look at the balance chemical equation. Fe2O3 plus carbon monoxide then produce 2 ferrous and 3 carbon dioxide. Question asks mixture of iron ore feed into the blast furnace could produce 56 kilogram of iron. They produce 56 kilogram of iron. Then calculate the mass of Fe2O3. Before find out the mass of Fe2O3, first, this is the first step. We have to calculate molar mass of Fe2O3. Okay, first we calculate molar mass. It is 160 gram of molar mass Fe2O3 hematite. So this is first step. Then when we consider the balanced chemical equation, mole ratio from equation. Look at the balanced chemical equation. 1 mole of Fe2O3 produce 2 mole of ferrous products. 2 mole of ferrous they produce. So that's why we know atomic mass unit of ferrous is, if it is 56, 2 mole of ferrous is 112 gram. We need to calculate it as in grams. So that's why answer is 112 grams. This is second step. So we can say 160 gram of Fe2O3 contain 112 gram of ferrous. Okay, they produced 160 gram of Fe2O3 produced 112 gram of ferrous. Okay, carefully remember these things. 160 gram of Fe2O3 produce 112 gram of ferrous. Okay, 160කින් ferrous gram 112ක් එයා produce කරනවා. ඊළඟට next blast furnace could produce 56 kilogram. The question already given us 56 kilogram produced by 56 kilogram of iron produced by blast furnace. So it is, we need to convert it into grams, 56,000 grams. So these are the steps before we calculating the mass of Fe2O3. Then we all know the before information. So that is why we can calculate mass of Fe2O3. Then Fe2O3 equal here. Remember all the things carefully. If 1060 gram over 112 gram, we can represent it is as gram, it is 80 gram. Okay, then after you can write down it as a gram also, it is kilogram. Okay, that is the answer. I hope you all understand what I am saying. If you have any doubts, you can ask me if you have any doubts. I think all are muted.
No doubts, teacher.
Is that clear, student?
Yes, teacher.
Okay, very good. Because always keep calculation part, always doing calculation parts. Don't complicated calculation part. You can solve the question step by step. First, Special thing is remember all the formulas that you need. Okay. Then we will move on to the question number 13. It is also regarding motion of straight line lesson question. Forward motion with acceleration. Is that clear, student? Shall I erase?
Okay, teacher.
Okay. Question number 13. Following data shows the way of changing velocity with the time of an object. Travel in a linear motion. Here, this shows time taken, then the other row shown velocity taken. Then first question they ask, state the time spent with the following situation in the motion. A forward motion with an acceleration. State the time spent. First, move with the constant velocity. Look at the table. If it is forward with constant velocity, what is the time spent? Velocity increase from 0 to 10. Here, velocity increase from 0 to 10. After 5th second, velocity, how it is, how occur the velocity? From 5th second to 9th second, it is
4 seconds.
move with the constant velocity. It is times, what is the time spent? Time interval 0 to 5 second. 0 to 5 second. Here, this is the 0 to 5 second. Time spent is 5 second. Answer is 5 second. Move with the constant velocity. For first question, velocity increase from 0 to 10. Velocity increase 0 to 10. Then constant velocity they ask. What is the answer? Constant, it is, yes, it is 4 seconds. Constant velocity 5 second to 9.457, 4, 5, 6, 7. Sorry, 5, 6, 7, 8, 9. It is 4 second. Move with the constant velocity 5 second to 9 second. It is 4 second. That is the answer for first question. Motion with constant velocity from 5 to 9. It is 4 second. Time spent it is 4. Time interval 8 second to 9 second, it is 4 seconds. Move with the constant velocity 5 second to 9 second, it is 4 second. That is the answer. What about move with the negative acceleration? Here, where's the negative acceleration occur? With negative acceleration, here it is negative acceleration, it is start from 9 second to 11 second. 10 to 11. Here, what is the answer for negative acceleration? What is the time spent the move with negative acceleration? It is 2, sorry, 2 second. Move with the negative acceleration from 9 second to 11 second, it is 2 second. Understand? I think you all are got the point. Okay, then we will move on to the another question. What is the value of uniform velocity moved in forward direction? What is the value of uniform velocity? Value of uniform velocity here?
10 ms minus 1.
Yes, very good. Uniform velocity all from 5th to 9 second, it is 10 ms minus 1. It is 10 ms minus 1. Uniform velocity in the forward direction. Here from 5th second to 9 second, it is uniform, it is a constant velocity. It is a forward direction, it is 10 ms minus 1. Then third question, draw the velocity time graph for the above data. How can we draw the velocity time graph? Okay. Velocity time graph. Velocity time graph. In seconds. Here, look at the table. In the time at rest, it is start at rest. Then first second velocity. Name it as okay. How can we draw this? From it is start from rest, then first second velocity it is 2. Then after, then another 3 second, another third second, it is 6 in the third second, in fourth second it is 8. Then constant velocity, in fifth second it is 10. In fourth second it is 8. Fifth second it is 10. Here we can go. Then after 11 second it is going to rest. Okay, that is the type of velocity time graph. It is start from rest. It is start from rest. Then that is the velocity time graph of above data. In first second velocity it is 2. First second velocity it is 2. Then after third second velocity, how much is that? It is 6. This is here, this is 6. Then after fourth second velocity, how much is that? It is 8. Then after 5, 6, 7, 8, 9, therefore there is 4 second. It is in a constant velocity. Here from fifth to